Good evening. First of all, we are Team Woody. We're gonna be discussing the case from Baby Max. My name is Jose Gonzalez, and our group members are Maya Casagrande, Son, and Lee Siam. To start, I'm gonna explain the challenge of the Baby Max, and it was finding a more sustainable method to deliver its products from its warehouse to its retail stores. Um, our main idea was to work with a circular supply chain. So this is also known like a circular economy. It's focused on sustainability by maximizing waste and maximizing the efficiency of our resource. Um, Also, circular supply chain aims to create a closed loop where products and materials are and resources are reused, refurbished, and remanufactured and recycled to extend their life cycle. So how it works, we have to design a circular economy, the material selection and life extension of the containers and pallets, recycling and distribution and logistics will be a key. So our solutions, or main solutions for this problem was the implementation of a new cargo organization, route planning, the implementation of a automotive inventory system, the use of dollies and pallet jacks, uh, training and efficiency program, and for further steps, like the next step that the company should take is investing in electrical bands.
Hello, I'm Nishina, and I will explain the solution. First, the use milk powder cans with a net content of 900 grams of milk powder as reference. They hit 17.5 centimeter, diameter 7 meter, 30 centimeter, and 2 points. The auto-cutting specification of one box of milk powder hit 20 centimeter with 30 centimeter, length 45 centimeter.
The reason we use milk powder cans of this size is that containers are used for small commodities and the pallets are used for large commodities. Because the enterprise of our case is a mother and baby company, milk powder is already a big item among small commodities. Under the premise of using containers of this size, products larger than one container can be considered to be transported by pallets. Assume that a container can hold 8 boxes of milk powder. The container size is 40 centimeter, width 60 centimeters, and length 90 centimeters. If we only use containers, the volume of the container is 0.216 stir, because there are a total of 70 containers can be carried. So the container's volume is 15.12 stir. So the space utilization is 90%. If we only use pallets, there are 6 pallets can be placed, and there are total of 432 boxes of milk powder. So the space utilization is 69.4%. And if we use pallets and containers, the pallet volume is 0.18 stir. So in the case of pallets and containers, it can be placed in total of 6 pallets and 24 containers. The space utilization is 31%. I'm okay.
Okay. So route planning consolidation. Because Baby Max trucks go from one store to another, it's easy to mix and match the orders. We will load the truck according to the size, order, and the location of the store. Because our solution is to solely use containers, we will be roughly utilizing 90% of the space inside the trucks. We can fit 70 containers using the placement method of 2 columns down, with 1 column having 5 layers and 7 rows across. This will help minimize our carbon footprint as well. So containers and pallets. The plastic for our containers will be high density polyurethane plastic. This plastic has excellent toughness and durability. This material can withstand heavy pressure and has tear and puncture resistance properties, which can effectively protect goods from damage. It can withstand the erosion of various chemical substances and will not be eroded by acid in alkali solutions, thus protecting the goods from damage. High-density polyurethane can also be recycled to reduce waste generation. In terms of promoting the sustainable development of the logistics industry, it can also reduce energy consumptions and carbon emissions due to its lightweight and excellent physical properties. High-density polyurethane can reduce energy consumption during transportation and reduce transportation costs. The raw material cost is about 8 yen to 12.2 yen per kilogram. If we purchase the large quantities according to container specifications designed by us, the price of a single container is around 90 to 104 yen. A wooden pallet is about 3 to 5 years for its lifespan, and an HDPE container is 10. So this will be a great long-term investment for Baby Max.
There are some basic costs according to the data given by the case. The total time cost, if we use pallets, is 10 hours and 15 minutes. If we don't use pallets, the time is 9 hours and 45 minutes. And the labor cost is 25 yuan per hour. So it's total 250 yuan. The pallet cost is 80 yuan per pallet. So 6 pallets equals 480 yuan. In the case of transporting the same amount of the same goods, if we use containers, the cost of one trip is 250 yuan. If we use pallets and containers, the total cost of one trip is 1,230 yuan. It contains 750 labor cost and 480 yuan pallet cost. And in this case, a truck can carry a third of the cargo that a truck can carry if we only use containers. So in this case, the cost triples, and the cost of pallets also needs to be paid. If we only use pallets, the total cost of one trip is 804 yuan. It includes 324 labor cost and 480 yuan pallet cost. So the cost went up 1.3 times, which is 324 yuan. I'm okay. And speaking of the carbon emission, a 4.2 meters truck vehicle displacement is 2.73 liter, and the average speed is 48 kilometers per hour. The fuel consumption is 0.1 to 0.18 liter per kilometer. So the travel time is 3 hours and 45 minutes. The total distance is around 180 kilometers. The carbon emission calculation formula equals kilometers multiplied fuel consumption multiplied emission factor. On the premise of transporting the same quantity of goods, if we only use containers, the carbon emission is around 1.3 ton. If we use pallets and containers, 24 containers, it can only carry 24 containers. So it's only a third of the cargo that a truck can carry if we only use containers. And it also needs 6 pallets. So carbon emission is triple, which is 3.9 ton. If we only use pallets, 6 pallets can be placed, and it can carry 432 boxes of milk powder. So the carbon emission went up 1.3 times, which is 1.69 ton. If only pallets are used, only 432 goods can be transported at a time, resulting in 1.3 tons of carbon emissions. Then the carbon emission per shipment is 0.003.1 ton. In this case, if we want to transport the same amount of goods that can be transported at one time using only containers, which can transport 560 goods one time, you need 1.69 tons of carbon emissions, which is 0.9 tons more than 1.3 tons using only containers. If only pallets are used, the carbon emission caused by 2 shipments are enough to ship 3 times when only containers are used. But if containers transported is used, 560 goods can be transported at one time, resulting in 1.3 tons of carbon emissions. Then the carbon emission of each good is 0.00232 ton, less than 0.00301 ton. And because only using pallets will cause a waste of various resources, we only use pallets to carry large goods, and small goods are carried by containers. I'm okay.
So as I stated before, one of our solutions was the implementation of an automated inventory system. This will help the warehouse to be able to complete and plan orders ahead of time. Inventory managers will be able to tell if they should send a large load with pallets or if they should send a small load using containers, or using only containers and pallets, or consolidating the orders as needed, using both pallets and containers. The use of the automated inventory system give a better inventory control and also give real-time data and reporting. This reduce the over and under stocking of the trucks. So with the automated inventory system, will give advantage to Babymax to forecast the demand of their different retail stores prior to loading the truck. So the impact that this solution has on the Babymax supply chain, the use of containers and pallets offer different benefits, such as efficiency on handling, transporting, and tracking, storing the goods or orders, improving the storage order, and like I said, the implementation of the automated inventory system. And on the impact on the Babymax is combining the use of pallets and container to reduce the labor costs and increase the truck turnaround times.
So for next steps, so since in China, sustainability certified companies can benefit from various government incentives and subsidies designed to promote sustainable business practices. These incentives may include tax benefits, grants, and access to favorable financing options, providing additional motivation for business to embrace sustainability. One example in China is China's automated energy saving product certification. So like we said in the beginning, we are hoping that they start to invest in electrical vans. We think that since they produced zero tailpipe emissions, meaning the trucks emit no carbon dioxide or nitrogen oxides, they are more energy efficient, which means they could travel farther than a gasoline truck, and the maintenance and operating costs of EVs require less maintenance than a traditional vehicle, which contributes to lower operations costs in the long run. So we definitely believe that investing in electrical vans will help in the future as well. So we're hoping that they take those next steps after the containers. And that's it.
Okay, thank you very much for that presentation. We'll start with the question and answer period. Richard, you want to start with your questions?
Yes. Are the other judges going to be asking questions on this video?
No, they'll be just watching the recording.
Okay, so I have a little bit of time here.
Yes, yes.
Well, thank you very much. Really, a very comprehensive and detailed and thoughtful proposal. And quite a bit of information to absorb in one 15-minute presentation. I just have a couple of questions. I guess one is, it seems like one of the keys to this proposal will be the planning of the individual shipments, the mixing and matching of the pallets and the containers and the routing and so on. So I know toward the end of your presentation, you touched on this. Could you elaborate on how that would be handled? It seems like if I understand the proposal, to get the most benefit out of this, there would have to be very careful planning of each shipment to make sure you're maximizing the combination of the various techniques that you've described here. So how would that be handled in practice?
So to start with the route planning, will be based on doing several examinations of the routes that they are already taken, that at what time they are more congested. So if the highway or the routes that they're taking at certain times are more congested to the traffic, it could lead to a delay on the delivery of the shipments. When it comes to the consolidation of using pallets and containers, we will have the help of the automotive inventory system that will help us to forecast what the different retail store needs. So for example, if they need a big load, we should use the pallets. And if they need a small order, we use containers. So that will consolidate using pallets and container. But our main goal is to use only containers so we can maximize the space utilization. As we noticed on the slide, only using containers, we can use 90% of the whole space of the truck. So this is where the automotive inventory system will come as a key player, because will give us a forecast on how many things each different stores will need in ahead of time, so we don't overload or underload the trucks.
Very interesting. I suppose the routing of the truck and how many stops it has to make and how much it has to unload at each stop would all come into the calculation, which could start to get pretty complicated. So how would you solve for that?
The unloading and loading in each different stops, or that's your question?
I guess the question is, if you have multiple stops and you're going to be combining pallets and containers, how would you plan for that in practice?
So
if you see what I mean, they could get in the way of each other. The mix would be different from one
like the organization
one day
inside
to the
truck.
next, and depending on what the route would be. So how would you handle that in the planning process?
So we will, so because the pallets cannot be stackable in top of one of another, or you cannot put a lot of orders in one pallet because they can trip down, we can add a second level to the truck where we can put all the containers on top and the pallets down. Or we can have a better organization where we can put the small orders first and we put the pallets after. Putting in priority what are the most important deliveries. So if there's different stores that need, for example, the first store is a small order and it's gonna be on containers, but the second store needs pallets, we will base our deliveries on the containers first. So we will put the pallets first, so the containers last. So when we open the truck, the containers are the first thing we can bring down. Everything is how we organize the space of the truck, but when it's coming when it comes to the consolidation of the pallets and containers, we have to put a focus on what is more important to deliver first, if that makes sense. So we will organize the truck depending on the needs of the different stores. So yeah.
I see. Okay. Just to change the subject, I had one other question. One of the early slides talked about the need to change the size of the package to be consistent with the size of the containers. In other words, I think you said the package size would need to be conformed so that the containers could be efficiently packed. Did I get that right?
So when it comes to the space utilization, what I think Son said, we use the example of the milk powder cans because that's what they frequently like sell. So those are the diameters that they use. So we base our containers based on those.
So you wouldn't be changing their packaging size?
No.
You would be adapting the size of the container to the existing package size. Okay, I was a little bit confused.
So it will be only one container can hold 8 boxes of milk powder. Yep. So each milk powder is 900 grams of milk powder. So it can hold a lot of the container basically.
Okay, I don't know what questions the other judges would ask, so I can't really anticipate that. Chung, do you have any questions you wanted to ask?
Yes, I had a couple of questions as well. Again, you mentioned that I think I can follow up on what you said about the container sizing and its size specifically for the milk containers. Now, these things could change. You said these things, you were saying the containers will last about 10 years. What would happen if your supplier changed the size of the container, of the milk containers? Have you thought about that? So why did you choose to custom make your container to fit your supplier's size when you have really no control over what happens to that size?
So that's a really good question. That's based on the future, but as what I can say is that because we are using a specific material, the high density polyethylene, the HDPE, and is recyclable. If this is like a hypothetical case, if our manufacturers decide to change the size of the box, we could rethink and see if we can manage to recycle the ones that we have, or the oldest containers we have, to make the new ones to the different size.
So why didn't you? Because of why didn't you size your containers to the size of the truck? So
we base our containers to basically have a better order and organization of the orders inside the truck, and for us the best like diameters that we can use for the containers to hold the maximum amount of things in a like organized order was these diameters. But because Babymax is a huge company organization, and they can basically have a deal with the manufacturers to have a fixed package in order to have a streamlined supply chain. So there's no any like unexpected change that will disrupt the supply chain.
That's an interesting assumption. I mean, even Walmart can't tell Coca-Cola what size to make their cans. So how come Babymax can tell the milk powder what size to make their cans? Because they obviously sell more to so many companies other than Babymax. One of these large milk companies, they would sell to many other companies, the supermarkets and so on. So what makes you think that Babymax would have so much power over these companies that they would not change their size because of Babymax?
I want to add that the reason we use milk powder cans of this size is that containers are used for small commodities and the pallets are used for large commodities. Because the specification of milk powder cans in this size, this size cans is already selling in Baby Max, this company. So, and in the market, the amount of outer packaging is this size too. So we use the average specification to calculate the data.
I see.
And milk powder is already a big item among small commodities. Under the premise of using containers of this size, products larger than one container can be considered to be transported by pallets.
Okay, all right, that's fine. Now a question about your carbon emissions calculations, the reductions in carbon emissions. I think that's very important for what this whole case is about, is reducing carbon emissions. I don't really understand your calculations, because carbon emissions, it's really based on how many trips or how many kilometers the truck's going to travel, right? Regardless if it's
Yes.
2/3 full, 1/3 full, or pretty much.
Yes.
It doesn't really make any difference. And because, like you understood, it does on a milk run. So by reducing one stop, it would not change, or the distance it travels on that route. So I'm kind of questioning your calculations. How much travel can you reduce by using your containers? Because if you're still making the same trips, same number of trips, regardless whether it's full or not as full, the carbon emissions would be the same.
So based on our calculations, this go hands to hand with the space of utilization. So as you can see, only containers have a space utilization of 90%. This means that if we use only containers, then we are gonna be doing less trips than using only containers and pallets. Because, for example, if we use containers and pallets, we have a space utilization of 31%. This means that we're gonna be doing more deliveries. In the long run, we will be we'll have more carbon emissions. So if
my question is, if you, let's say, you have 90% versus 80% space utilization. Okay, let's say 80% versus 90%. The number of trips you would make would be exactly the same on a truck. It wouldn't make any difference on how many kilometers truck would travel, unless in reality, trucks have to travel regardless if it's 75%, 80%, 90%, and then we have the same emissions would be exactly the same. Just because you increase the space utilization, it would not change the carbon emissions whatsoever, unless you can reduce the number of trips.
Yes, so by maximizing the space inside the truck, you're reducing the trips that you're doing, because if you maximize the space inside the truck, you don't have to hold inventory on your warehouse to stock the other truck, because that 10% left on that truck is not, like when it comes to the carbon emission, that how we calculate it is how many trips in total we're doing. So with the only pallets, we're only using, I'm gonna put the example of only pallets, we're using 85%, right? So that 15% space that's left is gonna be stuck in the warehouse. So the next trip, we have to put the 15% into the truck, and that other 15% is gonna be remaining. While in only containers, only 5% of the whole space is not gonna be usable. So in the long run, only containers are gonna do 11 trips, while only pallets are gonna be doing 12 trips, 13 trips to deliver all the orders. That's how we will reduce the carbon emission. I don't know if that's the answer you're looking for, but that's why I understand by your question.
Yeah, that's what I'm trying to get. That's why I'm questioning your calculations. because I questioned that, I think, last time as well, when you presented about your calculations in practical sense, it doesn't really make any sense, because if it's a couple of percent difference in the real life, it really wouldn't be any difference. Because of the loading, you're based on various, you're assuming you can always load at 90%, always at 85%, and then that couple of percent is going to make a difference in the long run. Maybe I'll reduce one trip at some point in 1 year, but I think over, so that's one of your calculations. I have some doubts about the numbers, about all those calculations. Anyway, I think that's the time we have for the questions. Thank you very much for your presentation. So we'll find out the results toward, I guess, the early next week. So good luck. Thank
Okay.
you.
I have a question.
Yes.
So based on what you said about only a small percent is gonna be reduced, or only we're gonna save one delivery. You can see on the carbon emission, the reduction between one to another is a small percentage. So that correlates with what you're saying.
Mhm. But in reality, we're saying in reality, in a real world application, would that really make any difference? That's the question.
Yeah.
So are we really saving anything? Okay. Well, thank
Yep.
you very much.
Yeah. Have a good night. Thank
Okay.
you.
Thank
Yes,
you.
bye.
Thank you.